So what did you get for the canopy storage at this time step? The previous time step, let's look at the previous time step storage. Previous time step, the canopy storage was 0.1, and if you remember, the maximum storage in the canopy is 0.1 inches. So what's the canopy storage at this time step? 0.1. Okay, so that's not hard. So we'll just enter 0.1. So the first thing is the canopy storage, that's 0.1. Okay, so what about the overflow? What is the overflow going to be from that? Yeah, so 0.4. So we can take that and enter 0.4 here.
Enter 0.4 here.
Okay. All right, so how about this? If we go back to these 5 steps. How come I'm hearing that? So go back to these 5 steps, and I add my storage from the precipitation to the canopy and soil surface. So how much should I unplug this microphone? Okay. Well, maybe it's okay. So how much water is at on the soil surface, I guess, at this time step? So obviously 0.4 is going to go to the soil surface, but then I have a certain amount of infiltration. And how do I get the infiltration? Yeah. What's that? Yeah. So the infiltration is 0.1 inches per hour. And we have 1 hour, right? So 0.1 inches goes into the soil. So the amount what's the amount that's left on the soil surface? So 0.1 goes down here, and the previous time step I had 0.3. Yeah, so anyway, maybe I'll just give you the answer, and you can check your answer. The answers are actually, I'm not sure that you have the answers. I can give this to you. Maybe I'll leave it on this computer. It's on this computer, the answers. So here's the answers. So I get 0.01 that infiltrates. The amount of water is 0.3, and 0.39 runs off. So that's that. And it's been a long time since I've done this, so actually maybe I shouldn't have had you do it because I can't remember all the exact equations and things. But this is how, and you have these slides, so you can study this in more detail if you're interested in how this works. Did anybody get, what did you get for the values? Did you get close to these values? So there's 0.3 on this soil. I think you got that.
Yeah, but I think I didn't say the whole component, but for example for the groundwater 1, I made a calculation and a little bit different. For example, 4.4 point almost 1 year. I'm not sure. Maybe I used another
Okay. Well. All right. Let's just continue on. So you can use this SMA method for modeling the Nile River Basin. And this is what we did with the Friend Nile project. This was 5-10 years ago. We did the Friend Nile project. And in that project we did a study of some of the sub-basins in the Nile River. And we used this SMA method to compute the losses and the base flow in our watershed. And so it has all, we've already talked about the different layers. The way to get some, there is a way to get some of these parameters, and these slides kind of explain how to get some of these parameters. So the canopy storage capacity, you can get those. These are some values you can use for canopy storage capacity. And so for different types of areas, these are the different storage capacities for these areas. So if you have forests, you have a lot of capacity. If you just have general vegetation, the capacity is a little bit lower. The maximum surface storage, these are some guidelines on how to get the values for maximum surface storage. And you have this table. The maximum soil infiltration rate, these are the values for the soil infiltration rate. So for clay, you have lower infiltration rates, 0.02, and for sand, you have higher infiltration rates. I guess I'm not recording. Let me, or maybe I am. I think I am still recording. Okay, and then soil percolation rates, same thing. You can use this table to get your soil percolation rates. The soil storage, it's up to 20 inches depending on the depth of vegetation rooting, and it can be estimated from a runoff hydrograph after a long dry period. So you just use a kind of calibrate to a runoff hydrograph after a long dry period, and you can estimate that value. So when you do an SMA model, you have to enter the percent of initial storage for each of these 5 layers in your SMA model. So you just enter the percent of initial storage, and you have to estimate it. Usually what you do is start at 0% and then calibrate those values to match your observed data. So here are some calibrated values, some sample calibrated values. You may have some other values, but these are maybe a good starting point for a simulation. And when you're doing the SMA method, you need to define some way to transform your hydrograph, so some kind of unit hydrograph method. And the recommended method is to use the Clark method for long-term simulations. And WMS has these different equations for estimating the Clark method parameters. The parameters you need are the lag time and then the Clark's R, which is a storage factor. So to set up a long-term simulation, these are the steps to follow. And these are basically the steps to set up an HMS model. So you delineate your watershed, set your starting and ending time, and define your SMA parameters, your initial conditions. Define the Clark hydrograph transform and your base flow parameter, linear reservoir base flow parameters. You export your model to HMS, enter your precipitation data and evapotranspiration data into HMS, and enter your observed flow data values, so your observations. You run your HMS simulation and then compare the computed versus observed data, and you can calibrate. You can either use an automated calibration in HMS, or you can manually calibrate your values. So that's the steps. And we did this watershed in Tanzania, and this is the precipitation over 7 years that we used. These are the observed flow rates from that watershed, and then we ran an initial run and got our observed and computed values. Then we calibrated those values, and then the red is the observed, the blue is the computed values. And so you can use the SMA method to do the Nile River watershed long-term modeling, or whatever watershed you want. You can model that using the SMA method. And those slides give you the tables and things like that you need to do that. Just at least start with the simulation. Do you have any questions about that? Okay. So maybe you can define gridded precipitation for using. You can use gridded precipitation with HMS, but I've never done it with a long-term simulation, so I don't know how well it will work with a long-term simulation. But you could try it. And
which format does HMS can use for those text format or anything? Which format?
Well, HMS uses something called it just uses a DSS file, but WMS, I don't know if we're going to talk about gridded precipitation. Maybe on the last day we'll talk about gridded precipitation. I'd have to look at our schedule. But if we do talk about gridded precipitation, there's a workshop, and it's on our website. You could download, and I might have included the workshop in your PDF files. Let's look here. So this workshop here, there's a workshop that you can go through. Like if you go to XMS Wiki, let's search for, if you just search for the WMS tutorials, on the Learning Center, so you can go to the Learning Center and it'll have a workshop that shows you how to do gridded precipitation in HMS, just under the WMS tutorials. So down here, these are all of our tutorials. One of them is HMS. using NextRad rainfall data in an HMS model. That's the one you want. And that shows you how to use gridded precipitation. It's just it uses ArcInfo ASCII grid files. That's the format that we use. ArcInfo ASCII grid.
Our ASCII.
Yeah.
You can take ASCII.
ArcInfo ASCII grid. But this workshop shows you how to do that. Any other questions about this? Okay, one other thing I wanted to mention is that on your computer, under the PDF files, you have a PDF file that is called 10C Lesson Long-Term Nile. So this is a paper that we wrote preparing long-term watershed simulations for the Nile River Basin. And I just included this just for your interest. If you're interested in doing that, you can look through this paper, and it explains how the HMS SMA method works. It has all these tables that we've talked about. So it has how to get the input parameters, how to do the computations, and it has the tables. So these different tables that we use to get our input parameters to the SMA method. So you can look at this paper. There's still some parameters that are hard to get, and but this is all that I've had experience with long-term simulations is this method, and so it's the one that I would recommend. Dr. Iman said that there is a method, I guess, that uses the curve number values, but I had no experience with using the curve number values for long-term simulations, so I don't know about that. And I don't know if HMS supports that method, but you could research that and look into it. My guess is it probably does not support the long-term simulation for curve numbers. So what I would use is the SMA method if you're using HMS. Any questions about that? So what I want to do now is we're going to spend 45 minutes, and there are two things that we can do. What I'd like for everybody to do is to set up a model, an HMS model, for anywhere that you're interested in. So you're going to download your data, just like we've talked about with HMS, and like I've demonstrated. You're going to download data for an area that you're interested in, set up an HMS model for that area, and you might not be able to download, well, you do have the soils and land use data on your computers for all of Egypt, basically. So you can use that data, or you can just define your own curve number values, but set up your own HMS model for an area that you're interested in. And we're going to do that until 11:30. Then at 11:30 we're going to have another lecture about swim. That's what we're going to talk about. So we're going to talk about swim at 11:30. Set up a model for any area that you're interested in. It doesn't matter, and you're going to do it on your own. There's no workshop to do it. And if you have time after that, then there is a workshop that's included with this lecture. It's called HMS Long Term Simulation, and the files for this are in a directory on your computer called HMS Long Term, or Long Term. So longterm.zip. So this file has the files you need for this workshop. So do a model for an area that you're interested in. Does everybody understand what to do? You're going to set up an HMS model for any area that you want. And if you're done with that, if you get finished with that, then you can run through this HMS Long Term simulation workshop. And I'll be coming around and helping people with the workshop. If you have any questions, just ask. Yeah, whatever area you want. You're going to decide. So you decide what area you want to model.
But do you think the time 1 hour is enough to do this exercise and also to run long-term simulation?
Okay, you might not be able to do the long-term simulation tutorial. You might not be able to finish that. But that's okay. You can do that at home or later after the course. But the main thing is just set up a model for an area that you're interested in. I know some people have been working on their own models, so you can use that, or just find an area that you're